Okay, so you're a backend engineer, right? Your servers are beefy, all the metrics on your dashboard look green, but the tickets? Oh, the tickets keep rolling in. Hey, the app is slow. You've checked the CPU, the memory, the whole infrastructure. Everything looks fine. So where is the fire? Right there. Just stop. Before you even think about spinning up another server or bugging your cloud provider, just take a deep breath. Because here's the thing, the answer probably isn't throwing more hardware at the problem. I'd say 9 times out of 10, the bottleneck has nothing to do with your infrastructure. It's hiding somewhere in your own application logic. And that's exactly what this is. Think of it as your tactical field guide, a 30-minute diagnostic you can run, literally right now, to find the exact lines of code that are putting a chokehold on your performance. So, let's get into it. All right, first up on the checklist, and honestly, this is where you're going to find like 80% of your problems, is the database. Your application is talking to it all day, every day. We just need to figure out if that conversation has turned, well, toxic. And yeah, I mean that quite literally. You know, the single most common performance killer I see is an application that's basically launching a denial of service attack against its own database. It's an inside job, and it has a name, the N+1 query problem. So here's how it goes down. Your code wants a list of items, right? Let's say 100 products. That's one query. So far, so good. But then, inside a loop, it goes back to the database to get the seller's info for the first product, and then the second, and the third. That's 100 times more queries. You see it? 1 plus n. It is death by 1,000 cuts, and it's probably happening in your logs right now. And just look at the damage this causes. We're not talking about a tiny 10% optimization here. We are talking about going from over a full second of latency, which your users absolutely feel, down to just 20 milliseconds. That is a 50 times improvement. This is literally the difference between a happy user and an abandoned shopping cart. So how do you fix this mess? Well, the technique is called eager loading. All you do is find where you're making that first big query, and you tell your ORM, using a method like include or select related, to just grab all that extra seller data at the same time, in one big efficient query. It's often just a one-line change that can wipe out hundreds of database calls. All right, so you've just cleaned up your database calls? Awesome. Now for step 2 of the playbook. Let's stop making so many of those calls in the first place. It's time to audit your cache. The way to think about a cache is like a high-speed shield for your database. You can see it in this diagram here. Instead of every single service just hammering your main database for the same piece of data over and over again, they ask the cache first. If the cache has it, boom, the response is almost instant, and your poor database never even gets bothered. But here's the deal. A cache you don't measure is just a prayer. So this is your immediate action item. Go find your cache hit rate. That number is your source of truth. It tells you what percentage of requests your cache is actually handling. And if that number is low, say under 80%, then what you have is a very expensive, very fast, and very useless server that is not doing its job. Now, while you're at it, check if you're even using the right tool. The choice usually boils down to Redis versus Memcached, and the question you have to ask is, what is my data's job? If all it needs to do is store and retrieve simple keys and values really, really fast, Memcached is like a Formula One car. But if your data needs to do work, if you need queues or counters or leaderboards, then you absolutely need the advanced data structures you get with Redis. Using the wrong one here is such a classic performance trap. Okay, database is clean, cache is working hard. So for step 3, let's look at how your application itself works. How does it handle doing more than one thing at a time? This is all about concurrency. And the biggest performance killer here is something called blocking I/O. So picture a thread in your app as a worker. When that worker has to make a network call to some other API, blocking I/O means that worker just stops, sits down, stares at the wall, and waits. It's a total waste of CPU time. An asynchronous worker, though, it fires off that request and immediately grabs the next job. It never, ever waits. Your goal is to get rid of all the waiters. This all leads to the one fundamental question you have to ask about your application's workload. Is it CPU bound or is it I/O bound? In other words, is it spending most of its time thinking, doing heavy calculations, or is it spending most of its time waiting for API calls, waiting for the database, waiting for the disk? You have to know the answer, because that answer tells you exactly how to size your thread pools. If your work is I/O bound, that means lots of waiting, you actually need more threads, so some can be working while others are waiting. But if it's CPU bound, all thinking, no waiting, then too many threads will just stumble over each other fighting for the processor. For those CPU bound tasks, a good rule of thumb to start with is setting your thread count to the number of CPU cores you have, +1. It's a great starting point, but it's not a silver bullet. Okay, that's enough theory. Let's see this whole playbook in action. Here's a quick story about how this exact diagnostic process saved an e-commerce platform right in the middle of a massive flash sale. So the platform was just buckling under all the traffic. Following our playbook, they went straight to step 2, auditing their cache. Turns out they were using Memcached, which is great for simple stuff. But their big bottleneck was real-time inventory management, which needed complex queues and atomic operations. They were using the wrong tool for the job. The diagnosis was crystal clear. They swapped out Memcached for Redis, specifically so they could use its powerful built-in data structures. They completely rebuilt their inventory system around Redis lists, and they turned that massive bottleneck into a super high-throughput, event-driven process. And the result? I mean, just look at this chart. A 30% drop in the time it took to update a shopping cart. And this was during peak traffic. This wasn't some lucky guess. It was a direct result of diagnosing the workload, asking the right questions, and picking the right tool. So let's wrap this all up into your new playbook. This should be your standard operating procedure anytime you hear those dreaded words, "the app is slow." Here it is, your 30-minute checklist. Number 1, go on a hunt for N+1 queries using your logs and APM tools. Number 2, audit your cache. Get that hit rate and make sure you're using the right engine for the job. And number 3, diagnose your thread pools. Figure out if you're I/O or CPU bound and then tune them accordingly. That's it. That 3-step process will uncover the root cause of most of the performance fires you're ever going to fight. The playbook is officially in your hands now. So the only real question left is, what's the first bottleneck you're going to find?